Good morning. I'm Mohammad Wasim. I said that in second part of the presentation I will go to say about the glass. So I am here to say about the glass in detail. So glass is defined as a hard, brittle, transparent, translucent material which is chiefly the compound of silica with varying proportions of the oxide, carbonates of sodium, potassium and other minerals, which means that silica will be major proportion, sand will be major proportion. For example, 80% sand will be there, other components will be 20%. For example, 70% sand will be there, other components will be 30%. So uh, this is the definition of the glass. So constituent of the glass, what are the constituent that will be there in the glass and why we are adding in the glass. So silica will be in major proportion and it is a major component of the glass. Nearly 80 to 90% silica will be there, 60 to 90% or 80 to 90% silica will be there. Sodium and potassium carbonate are also a good major component, minor component. Sodium and potassium carbonate are minor component as compared to the silica, and they are uh, they are used to reduce the melting point of the mixture and also to impart the viscosity of the molten glass. The sodium and potassium carbonates will give the viscosity to the molten glass so that they can the molten glass can flow easily through the mold. Lead oxide, lead oxide is there, lead oxide is there. So lead oxide, what it will do is it provide shiny surface of the glass. It is added to make the glass shiny. So lead oxide is used. Coloring substances are there. Coloring substances are used to color the glass. If we want a product of the glass in a particular color, so these substances are used. I have not mentioned all the substances, but these substances I have mentioned as an examples. MgO is added to the mixture of the glass for getting violet color. Cobalt and nickel are added to get black color. Mechanical properties of the, as a mechanical engineer, these are very important properties which we should have to remember. Compressive strength is 600 to 1200 mn per meter square. Tensile strength is 600 to 700 mn per meter square. As glass can also be defined as a super cooled liquid, so it does not have definite crystalline structure. As we know that it is extremely brittle. As we know that all the chemicals are stored. If we see in the laboratory, the chemicals are stored in the glass tumbler or in the glass flask or in any other test tube. We can put the chemicals in the test tube as well as any glass flask, as well as in any glass beaker. So why we are keeping it is not attacked by any chemical reagents. As we know that it does not undergo rusting or corrosion, so it cannot undergo corrosion or rusting. So we are saying that it is not affected by the air or water. Manufacturing of the glass, there are 3 steps for the manufacturing of the glass. First is fusion of raw materials. Second is working with molten glass. Third is annealing. working with molten mass or molten glass. Third one is annealing. First what we will do is, in the diagram you will understand good. So these are the components we will pour. For example, in the first container we have poured Na2CO3. In the second container, if we have poured CaCO3. In the third we have poured SiO2. In the fourth we have poured, for example, potassium carbonate. So what it will do is, for small proportions it will go under this pipe, and it will get mixed thoroughly. These all mixtures will mixed thoroughly. In the second container, here it is not there, but it will there. In the second container, cullet is added. What is cullet? Cullet are the old broken pieces of the same glass. They are the old broken pieces of the same glass. Cullet will provide the body of the glass, will help in providing the body of the glass. So cullet is added along with this constituent. What we have added? Na2CO3 plus CaCO3 plus also SiO2 plus KCO3 plus cullet, the broken pieces of the glass. What they are mixed very thoroughly. First they are mixed very thoroughly, then they are heated up to the temperature of 1000 degrees centigrade. So what will get? The solid mixture will convert into liquefied. It will be liquid, in the liquid form, and the molten liquid will be poured into the mold. The molten liquid will be poured into the mold. It is a production of the float glass, but there will be a mold in which the molten liquid will be poured. Then the molten liquid will be poured, and what will happen is annealing. The last step will take place. The mold or the product will pass through the different chambers of higher temperature zone to the lower temperature zone. The product is made by the mold cavity filling. So that mold cavity will pass slowly through the higher temperature zone to the lower temperature zone. What will happen? Slow cooling process will happen. Good quality product will be obtained finally. So this is the process of the, and what as a what the chemical reaction will happen, we will see. Na2CO3 plus CaCO3 plus SiO2. There is silicon dioxide, cullet, I have as mentioned, the broken pieces of the old glass of the same broken pieces of the old glass. So CaCO3, calcium carbonate, sodium carbonate, they are mixed, and this glass is obtained. Na2CO3, Na2SiO3, CaSiO3 plus 4SiO2 plus CO2. This is the glass we are getting. So as I said, liquid glass is poured into the mold, and then the glass passes through the high temperature zone to the lower temperature zone very slowly. So we will get good quality of the glass. So classification of the glass. These three are the major classifications of the glass. Soda lime glass. These are the three glasses: soda lime glass, flint glass, Pyrex glass. These are the three glasses which we will use in our day-to-day life. Soda lime glass. Soda lime glass is a glass. In the name itself it is there, soda, lime. It contains soda, it contains sand, it contains lime. Sand will be greater proportion, that is 75% sand will be there, 12% soda will be there, 12% lime will be there, CaO, lime will be CaO, calcium oxide. Sand will be there, 1% alumina, that is Al2O3 will be there. Flint glass. So soda lime glass. Soda lime glass is the cheapest quality of the glass. It is very cheap. So it is used in the laboratories as well as window glass, plate glass. So for making the window glass it is used soda lime glass. Flint glass. Flint glass is also known as the lead oxide glass because it contains the lead oxide. So the composition of the flint glass is 60% of the sand will be there, red lead will be 20% will be there, potash will be 10%, 10% waste glass, that is cullet. This is cullet, waste glass pass. Applications of the flint glass is optical glass, thermometers it is used, laboratory apparatus it will be used. So in every glass more percent will be sand, and another cost is red lead 20% will be there, potash 10% will be waste glass parts. Pyrex glass. Pyrex glass is the glass, and also I forgot that flint glass also used for the optical glasses which we'll use in our daily life. That lenses will be there na, concave lens, convex lens, all the lenses are made by the flint glass, Pyrex glass. So now coming to the Pyrex glass, the difference it is good as compared to the flint as well as the soda lime glass, because what will happen is soda lime glass and the flint glass cannot withstand higher temperature and cannot withstand the sudden temperature change. So Pyrex glass is used. This glass can withstand sudden temperature change. It has high melting point. Composition is 80% sand, boron oxide will be there. This is the separate component will be there. Al2O3 alumina will be there. This is alumina will be greater percent as compared to the soda lime, and boron oxide will be the extra component which is not there in the soda lime as well as flint glass. Boron oxide is 10%, NaO is 6%, and Al2O3 is 4%. So applications are laboratory equipments, cooking utensils, etc. Annealing glass. So what will happen is, what annealing is done to the glass, that is slow cooling is done to the glass to obtain the good quality of the glass. If we cool the molten glass very rapidly, what will happen, it will become brittle and it will break. It breaks. If we touch also it will break if we rapid cool means. Okay, if we strike something also it will break if we rapid. So good